Predictive modeling. Now, again, I said at the beginning, predictive modeling is a subset of concurrent analytics. And predictive modeling is simply a class or a family of statistical analyses where the goal is to predict an event or a behavior or an outcome using a set, a multivariate, what we call a multivariate set of predictors. Multivariate simply means that we're using more than two variables at a time in any particular analysis. So a predictive model means, you know, a simple way of looking at it. I'm going to, I'll give you a great example of what's happening a lot now. A lot of our clients are opening new or modified either women's healthcare centers and or ortho centers. So they're funneling a lot of the ortho into the quote-unquote ortho center, and they're centralizing the majority of the women's health services through the women's health center. So any female going in for probably 75% of what she's going to be treated for, she has to go through the women's health center. So what I'm trying to do from a predictive modeling standpoint is find out which pile of variables or which set of variables will allow me to predict which women, for example, have the highest likelihood of looking like someone who might need mammography screening services or certain types of lab services or hip replacement, you know, if that's coming out of the ortho center, for example. So all I'm really doing is I'm using a set of variables at the same time, simultaneously from a multivariate analytics standpoint to predict something. Here's a nice little example of a sort of an overly simplistic predictive model for hip replacement surgery. And, you know, one of the rules of thumb in statistics, you always start at the right, move to the left, so start at the outcome. We have hip replacement surgery. That we know. So let's move backwards and say, well, what are some of the things that predict, which predictors have higher weights than other predictives? When I say a weight, I mean the predictive strength for that particular variable. And if I look at the predictors on the left here, I see that, you know, for anybody who knows a little bit about hip replacement surgery, these are some of the factors that are in some of my current hip replacement models. So you have number of radiology visits, BMI. BMI is actually since about 2013, 2012, BMI is factoring into so many of the different models these days. It's actually scary. It's a precursor to a lot of things, a lot of procedures. Medicare supplement, that has a lot to do with hip replacement surgery because it could be, well, what are they getting for the hip replacement? Are they getting plastic and steel? Do they have a supplement? Are they going to upgrade to titanium? So on and so forth. So there's a lot going on in terms of possible cross-sell, upsell opportunities. Reading books, the reason why that's in there is because older folks, when you're looking at the appended consumer data, in this case Experian, there's certain variables that always pop in models that involve older folks. So if we're looking at an AFib model, hip replacement, other types of joint replacement model where you're going to find a lot of older folks, you should always see the interest in reading flag and a couple of others that always factor in for older folks. Those, and the cool part about those flags, they don't pop for young people. They pop only for older folks. Retired pension, that kind of helps. That's sort of related to the Medicare supplement. Mosaics, for those of you that know Mosaics from Experian, or maybe you know the niches from Equifax or any other type of clustering, you know, consumer-based clustering segmentation schemes. Most of our marketers are pretty savvy. They've used mosaics and other types of clustering and segmentation for years. So we would expect to see that in the algorithm, as well as MD specialist types. And depending on whether I'm doing a patient model or a non-patient model, in the patient model where I actually have the patient data, one of the things that's probably going to pop in the model, depending on the client, is the different types of MD specialists. So this is just an example of literally, this is a predictive model where each of those variables on the left-hand side, and there's a lot more predictors, but what I'm showing here are only the top predictors for a particular model. Each one of these variables, and that's what each of these things on the left is, each one of these variables has a predictive weight. That predictive weight, it's simply a mathematical equation, A plus B plus C plus D. All of that equals the predictive strength of someone, a prospect for a hip replacement who looks pretty much exactly like someone who already had that particular procedure.